Picture this. You grab 6 packs of baseball cards as gifts. Each pack has 24 cards inside. How many cards do you have in total? You could add 24 plus 24 plus 24 plus 24 plus 24 plus 24. That works, but it's slow. There's a faster way, and you already know its name. Multiplication. By the end of this video, you'll be able to multiply any whole numbers, even big ones with many digits, and use that skill to solve real problems. Let's start with the basic idea. Multiplication is just repeated addition. When we write 3 times 8, we mean add 8 to itself 3 times. Each number being multiplied is called a factor. The answer is called the product. So in 3 times 8 equals 24, both 3 and 8 are factors, and 24 is the product. We can write multiplication a few different ways. 3 times 8 can look like 3 with a cross symbol 8, or 3 with a dot 8, or 3 followed by 8 in parentheses. All three mean exactly the same thing. Let's see multiplication with a quick model. Picture 3 times 8 as a grid. 3 rows. 8 counters in each row. Count them up, 24 counters total. And here's something neat. Turn the grid sideways. Now it's 8 rows of 3. Still 24. The order of the factors doesn't change the answer. Before we tackle bigger numbers, let's lock in 2 special rules. First, the multiplication property of 0. Any number times 0 is 0. Always. Second, the identity property of multiplication. Any number times 1 stays exactly the same. 1 is called the multiplicative identity. Now, let's multiply bigger numbers. Try 15 times 4. We stack the numbers vertically, with 4 underneath the 15. Start on the right. 4 times 5 is 20. We write the 0 in the ones place and carry the 2 up above the tens column. Now, 4 times 1 is 4. Add the 2 we carried. 4 plus 2 is 6. Write the 6 in the tens place. Our answer is 60. Your turn. Pause the video and try 286 times 5 on paper. Then check your work as we go. Stack them up. 5 times 6 is 30, write 0, carry 3. Then 5 times 8 is 40, plus the 3 we carried makes 43, write 3, carry 4. Then 5 times 2 is 10, plus the 4 we carried makes 14, write all of 14. The product is 1,430. Now for 2-digit by 2-digit. Let's multiply 62 times 87. The key idea: we multiply by each digit of the bottom number separately. Each separate answer is called a partial product. First, multiply 62 by the 7 in the ones place. 7 times 2 is 14, write 4, carry 1. 7 times 6 is 42, plus the carried 1 is 43. Our first partial product is 434. Next, multiply 62 by the 8 in the tens place. Because the 8 is in the tens place, we write a 0 as a placeholder in the ones column of this row. Then 8 times 2 is 16, write 6, carry 1. 8 times 6 is 48, plus the carried 1 is 49. The second partial product is 4,960. Finally, add the partial products. 434 plus 4,960 equals 5,394. Here's a shortcut worth memorizing. When you multiply by 10, just tack on 1 0. Times 100, tack on 2 zeros. Times 1,000, 3 zeros. The pattern matches the number of zeros. Let's translate some word phrases into multiplication. The words times, product, and twice all signal multiplication. Twice specifically means times 2. So the product of 12 and 27 becomes 12 times 27, which equals 324. And twice 211 becomes 2 times 211, which equals 422. Let's solve a real problem. Umberto bought 4 sheets of stamps. Each sheet had 20 stamps. How many stamps did he buy total? We want the total, so we multiply. 4 times 20 is 80. Umberto bought 80 stamps. One more, and this one introduces area. Jen's kitchen ceiling is a rectangle, 9 feet long by 12 feet wide. What's the area? Area of a rectangle is length times width. 9 times 12 is 108. So the area is 108 square feet. Notice the units. When we multiply feet by feet, we get square feet. Look what you can do now. You can multiply any whole numbers, single digits, multi-digits, even with the zero shortcut. You can translate words into multiplication, and you can find the area of any rectangle. Next time, what if instead of grouping equal-sized bunches together, we split a big number into equal parts, and how is division secretly the opposite of what we just did?